Hello, welcome. Today we are going to be learning how to measure resistance. We want to learn how to measure the resistance of a resistor. And what is a resistor? A resistor, like I told us in the previous class, is any electrical material that prevents the free flow of electricity. When you have an electric circuit, the work of the resistor, or the definition of a resistor, is that electrical component or electrical material in the electric circuit that prevents the easy flow, the free flow of electricity. So how do we measure the ability of a resistor to prevent the free flow of electricity, which is resistance? How do we measure the resistance of a resistor? How can we measure the ability of a given resistor to prevent the easy flow of electricity? There are three ways to do that. Number one is that we can use the voltmeter ammeter method. Number two is that we can use the Weinstein bridge. We can use a setup or an apparatus known as Weinstein bridge. And number three, we can use another apparatus known as meter bridge. So three ways of measuring the resistance of a resistor are: number one, voltmeter ammeter method; number two, using a Weinstein bridge; number three, using a meter bridge. So I'm going to explain all these different ways of measuring resistance. So number one is that we can use voltmeter ammeter method, and this is the setup. You have an electric circuit. This is the voltmeter measuring the voltage across the terminals, and this is the ammeter measuring the current. So if you have a graph where you plot the values that are gotten from the ammeter reading and the voltmeter reading, as you vary the variable resistor, you're going to have something like this. This is the volt. If you have V1, you're going to have ammeter reading of I1. So when you have V1, you take it across. When you have I1, you take this reading. When you have V2, you take it to where you have I2, you take this. When you have V3, you take it to where you have I3. You understand? So you measure the corresponding values from the voltmeter and the ammeter. Then when you plot a straight line graph, which is what you're going to get, the slope, which is V all over I, is equal to the what? Resistance. And as you know that we said that Ohm's law states that V is equal to IR. So if you make R the subject of the formula, you have V all over I, which is also the slope that you will get from plotting the corresponding values of V and I. So that slope is the resistance. So that is one way of measuring the resistance of a resistor. Number two is by having a setup like this. This setup is known as a Weinstein bridge. This is done by comparing. When you have R unknown, the resistance that you don't know, R, but you know the resistance of R1, R2, and R3. How do you get to know the unknown resistance? So how do you do it? You have to adjust by closing the switches K2 and K1 until there is no deflection in the galvanometer. This is the galvanometer measuring the current. So once there is no deflection, then you balance this equation in this way. The unknown resistance R all over the opposite resistance R3 is equal to R1 all over the opposite resistance R2. So when you make such balance, you make R the subject of the formula, it will give you R1, R3 all over R2. Then you solve the calculation, it will give us the resistance of the unknown resistor. So that's number two way of measuring, by comparing the resistance of the ones you know with the one that you don't know, in order to get the value of the unknown. Now, using a meter bridge, the meter bridge is simply the practical type of Weinstein bridge used by comparing resistance of two resistors, R1 and R2, in relation to lengths L1, L2. So this Weinstein bridge and the meter bridge, they are very similar. only that you do comparison not just for resistance but also for length. So whenever you have a setup like this, which is a meter bridge, you also close the switch until you have no deflection in the galvanometer. That's when we have a balance point. Whenever you have a balance point, arrange this equation in this way: R1 all over R2 equal to L1 all over L2, L1 all over L2, R1 over R2 equal to L1 all over L2. Make R1 the one you're looking for the subject of the formula. You will now have to solve the calculation of R2 L1 all over L2. Once you find this is the one you're looking for. So you also use comparison to find this, just like the way you use here. Unlike using voltmeter ammeter method, where you use plotting of graph and picking readings of the voltmeter and the ammeter. So these are the ways you can use in measuring the resistance of a resistor. 3 ways, like I told us. If you want to measure the ability of a resistor to prevent the free flow of current in an electric circuit, there are 3 ways of doing that. Number 1, using the voltmeter ammeter method. Number 2, using the Augustine bridge method. And number 3, using the meter bridge method. So JAMB is going to ask you which of the following is not a way of, or is not a method of measuring resistance of a resistor. So whenever you see these as part of the options, know that there are ways of measuring the resistance of a resistor. Both meter method, Augustine bridge method, and meter bridge method. So in subsequent classes, we are going to use these equations that we prepared. The equation for Augustine bridge, the equation for meter bridge, to solve calculations. So take note of the balancing of this equation. R for Augustine bridge, R all over the opposite, this all over the opposite. Whereas for meter bridge, R1 over R2 all over L1 over L2. Thank you.